Okay, so in this lesson, we're going to look at section 1.6, solving linear systems. Again, algebraically, only this time using the elimination method. So our steps for the elimination method. Step number 1, you choose one variable to eliminate. Step number 2, you multiply the equations by a constant or constants if necessary to create one variable with the exact opposite coefficients. Step 3, add the equations together to eliminate the one variable. Step 4, solve for the remaining variable. Step 5, substitute the value of the variable you just solved for into either equation to solve for the other variable. And finally, write your solution as an ordered pair. So the gist of that, so we want to add the two equations together. In order to do that, we want to make one of the variables, either the x or the y, completely disappear. So in order for that to happen, they need to be exact opposites. So I look at this first set of equations. I have 2x plus 6y equals 10. Negative 3x minus 6y equals 9. I notice I have a positive 6y and a negative 6y. So this one is nice and easy. It's ready to just go ahead and add together. So I'm going to go ahead, 2x plus 6y equals 10. Negative 3x minus 6y equals 9. I'm ready to just add these two together as they are. So 2x minus 3x gives me negative x. My y's cancel. That's what we wanted. 10 plus 9, 19. Divide by negative 1, x equals negative 19. So now I can plug that into either equation that I started out with to find out what the y is. It doesn't matter which equation. I'll just pick the top equation. So 2 times instead of x, I'm going to plug in negative 19 plus 6y equals 10. So 2 times negative 19 gets me negative 38 plus 6y equals 10. Move the 38 to the other side, so I get 6y equals 48. Divide by 6, y equals 8. So my answer, negative 19, comma 8. That was a nice, easy one when we already had one of the variables already had exact opposite coefficients. So now let's look at one when that doesn't happen. So number 2, 4x plus 5y equals 13. 1/4 x minus 8y equals negative 22. Notice I have a 5y and an 8y. So if I wanted to get rid of my y's, I would have to multiply both top and bottom equations by something. So let's look at the x's. I have a 4x and a 1/4 x. I could very easily turn the 1/4 x into a negative 4x. So that's what we're going to do. So the top equation, 4x plus 5y equals 13, is going to stay the same. I'm going to take 1/4 x minus 8y equals negative 22. This equation, if I multiply the entire thing by negative 16, then I'm going to get a negative 4x here. So again, my top equation, 4x plus 5y equals 13, stays. 1/4 x times negative 16 becomes negative 4x. There's my opposite coefficients. Negative 8y times negative 16 gives me positive 128y. Negative 22 times negative 16 gives me positive 352. I'm now ready to add these two equations together. My x's cancel. 128y plus 5y gives me 133y. 13 plus 352 gives me, let's see, 365. Divide by 133, so I have y equals 365 divided by 133. Not very pretty, right? Okay, so now I want to go ahead and find out what my x is. I can plug that into either of the equations that we started out with. So let's see, if I plug it in up here, 4x plus 5 times 365 over 133 equals 13. So let's do 5 times 365. So here I have 4x plus 1825 over 133 equals 13. Subtract over, so 4x equals 13 minus 1825 over 133. I want to get a common denominator, so really I want this to be over 133. So 13 times 133 gives me 1729. So So I have 4x equals minus 18.85, negative 96 over 133. And finally, I want to divide everything by 4. So here I get x equals negative 96 over 532. We're going to simplify that. Let's see, I know that we could take a 4 out of both of these. So this becomes a 133. 96 divided by 4 is 24. So I get my answer, negative 24 over 133. Y was 365 over 133. Okay. So our answers don't always have to be nice, pretty whole numbers. Okay. All right, let's look at the back. Okay. So here we have 3 variables, x, y, and z. Okay. So we want to pick 2 equations, add them together to begin with. So right off the bat, I see the first 2 equations, the z's are opposite right off the bat. So we're going to do 2x plus y minus z equals 10, negative x plus 2y plus z equals 3. I'm ready to add these 2 together. So I get x plus 3y equals 13. Our z's cancel. Okay. Now I need to take 2 other equations and eliminate a z. So I can either take the top and bottom or the second and the third. Either way, I'm going to have to multiply one of them by something. So if I take the top equation, I can multiply it by 3. So I'm going to take 2x plus y minus z equals 10 and multiply it by 3. So then I get 6x plus 3y minus 3z equals 30. I'm going to add to that the bottom equation, plus x plus 2y plus 3z equals 13. So I have 7x plus 5y, my z's cancel, equal 43. Realize that this was a negative 30. So that's negative 30, so that is going to change this number right here. So it's really negative 30 plus 13, which is a negative 17 right there. So now I need to take these 2 equations and combine them to get rid of either an x or a y. I see I have 7x and an x, so I'm going to multiply this equation by negative 7. So then I get negative 7x minus 21y equals 7 times 13 equals 91. Oh, I made that same mistake there. This was a negative 10. So this is going to be a negative 7. Okay, so this is going to be now positive 49. So now I need to combine these 2. So 7x plus 5y equals negative 17. I can now add these 2 together. My x's cancel. So negative 21y plus 5y gives me negative 16y. 49 minus 17 gets me 32. Divide by negative 16, I get y equals negative 2. I'm going to plug that into one of these equations that only had x's and y's. So if I take x plus 3 instead of y, 3 times negative 2 equals negative 7. If x minus 6 equals negative 7, x equals negative 1. And now plug x and y both into any of the equations that I started out with and solve for z. So if I just take that top equation, 2 times negative 1 plus negative 2 minus z equals negative 10. I remembered that it was a negative 10 this time. So if negative 2 plus negative 2 minus z equals negative 10. So we have negative 4 minus z equals negative 10. Add 4. Negative z equals negative 6. Divide z equals 6. So now my ordered pair, I go in alphabetical order, x, y, and z. So x was negative 1, y negative 2, z 6. There's our answer. Let's do another one of those. Again, I see the top two. I can go ahead and add those two together. 2x minus y plus z equals 3. Add with x plus y plus z equals 5, because I already have opposite y's. So here I get 3x plus 2z equals 8. So now if I multiply the top equation by 2, so I'm going to basically multiply that equation by 2 to come over here. So I get 4x minus 2y plus 2z equals 6. This, let's see, should be a 4x plus 2y. So I have negative 4x plus 2y minus 2z equals 0. Add these together. My x's cancel. My y's cancel. My z's cancel. And I have 0 equals 6. That is not a true statement. 0 does not equal 6. So this is a no solution. Another one where, therefore, it is an inconsistent system. That is solving by elimination. Hey, buddy. How are you? How's you feeling?